Hello, so in this video we're going to be going through an example of a second order ODE again, and we're going to look at the case where we get two complex roots out, okay? So this is the thing which I want to solve. Remember, we look for a solution that looks something like this, so y equals e to the rt. We know it's going to look like that because the right hand side is equal to 0 and it's a linear case, okay? So this is the solution that we're generally looking for. Okay, so first things first, we need to put this into a characteristic equation. Again, the way which I write it is like this, so I write it out like that. Okay, I replace this by an r and this by a 2. Okay, because I see it's second, so the second derivative goes to an r squared. You don't have to do it this way, you can do it wherever you want. Okay, replace this by an r, because the first derivative. Okay, and this I just replace by 1, because it's effectively 1 times y, so it's just going to become 1 times r to the 0. Okay, this is my characteristic equation now, and I'm going to try and solve that. Now, I can't see any way to solve it directly, so I'm going to solve it using the quadratic equation. So r equals minus b. Well, at the moment, b is 1, so this is going to be minus 1, plus or minus the square root of b squared. So b squared at the moment is 1, so it's going to be 1 squared, which is 1, minus 4 times a, which is 1, times c, which is 1, so it's just going to be 1 minus 4. Square root of 1 minus 4 over 2 times a. So 2 times a, so 2 times 1, because a is 1. Okay. Now this 1 minus 4 goes to minus 3. Okay, so it's going to be minus 1 plus or minus the square root of a negative number. So I know it's immediately going to be complex. Okay, and I'm just going to write this. I'm just going to write this using, root of minus 3, root of a minus number. Basically what we do is we let the square root of negative 1 equal I. Okay, so basically what this is the same as 3 times minus 1. 3 times minus 1. So effectively this is the same as square root of 3 times square root of minus 1. And I've just let minus 1 equal I. So this is effectively now root 3 times I. Root 3 times I. Okay. So that's what we end up with. Okay, I'm just going to split it up. I'm just going to write it as minus a half plus or minus a half, or root 3 over 2. Root 3 over 2 times I. Okay, so I've just basically put this half over here and this half over here. So just split this up on the bottom, wrote this over half and wrote that over half. Okay, so now what I can say is that R1, let's call R1 the positive one. So R1 is minus a half plus root 3 over 2 times I. And let's call R2 the negative one. So in other words, we take that one, so it's going to be minus a half minus root 3 over 2 times I. Okay, so minus root 3 over 2 over I. So these are my two equations by roots. Remember what I'm looking for. I'm looking for an equation of the form y equals e to the rt. Yeah, I'm looking for that thing. So basically y1 is going to be that thing, I'll just place r1 in that thing. So r1 is that thing there. So we've got minus a half plus root 3 over 2 times I, and that's multiplied by t. And y2 is going to be e to the r2 times t. So in other words, R2 is going to be that thing there. So minus a half minus root 3 over 2 times I times t. Okay, so there we go. There we go. Okay, so now basically what we just do is we try and write this in, using Euler notation. So let's just multiply 3 by t. So we end up with minus a half times t plus root 3 over 2 times t times I. Okay, and this thing is going to become e to the minus half, similar kind of thing, times t minus root 3 over 2 times t times I. Okay, and actually I'm going to be a little bit sneaky again. I'm going to turn this into a plus and put the minus with the I. So it's still going to be the same thing as that, as what we just had before, but I've just written the minus, with the I. Okay. Okay, so now I'm just going to rewrite this out again. So e to the minus a half times t, just using separate powers. E to the root 3 over 2 times t times I. And this is going to become e to the minus a half times t times e to the root 3 over 2 times t. And this is times minus I. Okay, so now let's try and write it out using, using Euler's form. So this is just a real number. Okay, so this is going to become e to the minus a half. So actually, if I just write out y1 is equal to e to the minus a half, I'll leave that alone, times t. Okay, that's just going to be a real number. Times by, this is going to be, my complex number. So I'm going to treat this as theta, okay, effectively. So so that's what's going to go inside my angle. So cos of root 3 over 2 times t, plus I, so that's where the I comes from, sine of root 3 over 2 times t. Okay, and that's what my y1 is equal to. Similar kind of thing for y2, except instead of there being a plus, there's just going to be a minus thanks to this minus I. So there we are. Those are the two things written out now. Now remember, our general solution is going to be y1 plus y2, right? Plus y1 plus y2. Okay, with some constants in front of them, c1 and sorry, what have I written? I thought automatically written c2. There we go. So y is going to be y1 times by some constant plus c2 times by some constant. Okay, so what we're going to end up with? We're going to end up with c1 times y1, which is all of that thing. So what's the quickest way of writing it? Am I just going to be able to copy it and paste it? Let's hope so. So copy. Oops, let me just... Okay, so hopefully this will paste now. Hopefully this will paste. Come on, there we go. Just paste. Yes! Okay. So that's that thing. Make it a little bit smaller so it fits in a little bit better. So there we go. So that's just y1 now. Okay. Plus c2 times all of that thing. So actually, if I just paste it again, yeah, like that. Come on, you're almost there. Okay, that thing, but just replace it with a minus, because that's the only difference between y1 and y2, right? So just conjugates of each other. So, okay, let's try and expand this thing out then. And hopefully we should get a cancellation or something, or we can write it a little bit simpler. So what we're going to end up with, let me just expand this out. So c1 times all of this thing, and then I'm going to do c2 times all of that thing. So multiply through by all of that thing. And I'm just going to pause the video, write it out, and then hopefully, you know, rather than watching me write, effectively just expanding out a bracket, which I'm sure you can all do. So there we are. That's the whole thing written out for you. Now, you can see here that these two things are exactly identical, except they just differ by a constant. So in other words, I can take these two things out of this term. So in other words, I can take out e to the minus a half cos of root 3 over 2 times t, okay, and multiply that. Sorry, that's all multiplied by c1 plus c2. Okay, so I've basically just dealt with those terms now. Okay, notice that these two things are exactly the same as well. So if I take out plus I e to the minus a half t sine root 3 over 2 times t, okay, multiplied now, well, this is c1 minus c2. c1 minus c2. Okay, so this is c1 minus c2. Okay, so if I just let c1 plus c2, it's just going to be two numbers added together, so two constants added together. It's just going to be two numbers added together, so it's just going to be another constant. It's just going to be another number, another constant. So if I just let that thing equal c3, that thing equals c3, and likewise, similar kind of logic, two numbers take, two constants take away each other, so just going to be two numbers subtract each other. Just going to be another number, which is going to be treated as another constant, so I'm just going to call that c4. So in other words, what am I left with? This is going to be that thing multiplied by c3. So maybe if we just move that across a little bit. That's now c3 plus I times that thing, which is just going to be c4. It's just going to be c4. Okay, and that would be my final solution. So this is what y is now equal to. This is now what y is equal. That's my final solution. And again, if I was given initial data, I could probably find out what c3 was and c4 was. But effectively, you know, that is absolutely fine. And actually, I could go a little bit further and I could sort of take out like e to the half t or whatever. But to be honest with you, I'm not really that interested in doing that. You know, leaving it like that is absolutely fine.